you. Yeah, I'm going to just give you kind of a whirlwind tour of Deno and some subset of the features that were built into it, and I'll try to give some live demos. So we'll see how well this goes. Live demos are always a little bit scary. But maybe a little bit fun too, in case I fail. So yeah, Jeff gave me a nice intro, but my website's here and my Twitter's here. GitHub user number 80. I was there very early on, which may contribute to Node's success. Just working on that stuff very early. And yeah, these days I'm working on Deno. So the web is incredibly important, and like year after year, it just becomes more and more important. This wasn't super clear in, say, 2020. There was a time where maybe iPhone apps were going to replace the web, right? It wasn't super obvious. But I think now in 2023, it's pretty clear that the web is here to stay, and indeed is kind of the medium of human information, right? This is how you read your newspaper. This is how you interact with your bank. This is how you talk to your friends. This is how humans communicate with each other. It is incredibly important. And we've built so much infrastructure on the web at this point, the web being a very large set of different technologies. I think it is a very fair bet to say that the web is still going to be here 5 years from now, if not 10 or 20 years from now. And that is maybe unsurprising to you all, but technology is very, very difficult to predict. And there are very few situations where you can say 5 years from now, this technology is going to be here. And I think this is a rare exception. We are pretty sure that JavaScript, a central protocol of the web, central programming language, it will be here in the future because it's inherently tied to the web. And I think that further work in JavaScript is necessary. I think the tools that I and others developed 10 plus years ago with Node.js and NPM and the whole ecosystem around that are dating fairly poorly over the years. Well, let's just leave it at the fact that I think further investment here is necessary. So. With Node, my goal was to really force developers to have an easy way to build fast servers. And the core idea in Node, which was relatively new at the time, was to force people to use async I/O. You had to do non-blocking sockets as opposed to threading. And with JavaScript, this was all bundled up and packaged in a nice way that was easily understandable to front-end developers because they were used to non-blocking JavaScript in websites. They were used to handling buttons with on-click callbacks. It's very similar to how servers are handled in Node. When you get a new connection, you get an on-connection callback. But I think it's clear these days that more can be done beyond just doing async I/O. I think this is pretty table stakes, and yet developing servers is still hard. It's still something that we're stumbling across. We have a larger perspective these days on what it means to build an optimal server. It's not just something that runs on your laptop. It's something that needs to run across the entire world. And being able to configure that and manage that is a pretty complex situation. I'm sure you all have dealt with complex cloud configurations in some form or another. I'm sure many of you have dealt with Terraform. I'm sure you have thought about how to get good latency worldwide, right? Having a single instance of your application server in US East is not appropriate for all applications. Sometimes you need to serve users locally, say in Tokyo, and you are kind of bounded by speed of light problems. You have to be executing code close to where users reside. And gosh, there is just a insane amount of kind of software and workflows and tool change, especially in the JavaScript space, where with Node we kind of created this small core and let a broad ecosystem develop around it. I think not an unreasonable theory, and certainly was pretty successful. But because of kind of this wide range of tooling options in front of you when you sit down to program some server-side JavaScript, it takes a lot to understand what's going on. Or should you be using ESLint or TSLint or prettier? Like, there's all these kind of unknown questions that make it so that you kind of have to be an expert in the ecosystem in order to proceed correctly. Those are things that can be solved at the platform layer. And of course, I think we've all heard about the NPM supply chain security problems, where people can just publish any sort of code to the registry. And there's all sorts of nasty effects where, like, as soon as you link a dependency, you are potentially executing untrusted post-install scripts on your local device without you ever having to, without you ever agreeing to that, without really understanding that. That is a very bad situation. We cannot be executing untrusted code from the internet. This is a very bad problem. So, in some sense, Deno is a continuation of the Node project. It is pursuing the same goals, but just with an expanded perspective on what this means, on what optimal servers actually entail. So yeah, Deno is a next generation JavaScript runtime. It is secure by default, and I'll get into that. It is, I say JavaScript runtime because at the bottom layer it is JavaScript, but it treats TypeScript and JSX natively. So it really does understand TypeScript in particular, and understands the types and can do type checking and just handles that natively so that you are not left with trying to configure that on top of the platform. It has all sorts of tooling built into it, testing, linting, formatting, just to name a small subset. It is backwards compatible with Node and NPM. And it does pursue, it's trying to thread this needle between keeping true to web standards and really keeping the gap between browsers and server-side JavaScript as minimal as possible, but also being compatible with existing NPM modules, existing Node software. That's a difficult thing to do because the gap between NPM and Node is, the gap between the NPM ecosystem, the Node ecosystem, and where web browser standards are specified is quite large. So yeah, now let me attempt to do some demos here. We will see how well this goes. It's always a little scary. Let's see here. Is this visible to people? Okay, so in Deno, you can run programs directly from the command line, run URLs directly from the command line. And let me, can't copy and paste that, but okay, I'll just type it out. HTTPS deno.land std at 150.0 examples gist.ts. Actually, let me curl this URL first, just to give you an idea. This is some source code. This is a little program that posts gists to GitHub. Okay, so it takes a file as a parameter and uploads it. I'm going to run this file directly in a secure way with Deno. So I'm just going to Deno run that command line. And what you'll see is that, first of all, it doesn't just execute this thing. You immediately hit this permission prompt situation where it says, oh, Deno's trying to access this gist token. I have an environment variable that allows me to post to my GitHub. Do you want to allow access or deny access to this? So I will say yes. Well, then it fails because I haven't actually provided a file name here. So what I'm going to do is upload my Etsy password file. Very secure. So I will allow it to read the environment variable, and then you see that it's trying to access the file Etsy password. I will allow that. And now it's trying to post to api.github.com, so I will allow that. And finally, it has actually uploaded the gist, and luckily my Etsy password file is shadowed here, and it doesn't actually contain any secret information, so it's not such a big deal. So just as an example of running programs securely, obviously if it's going to be accessing your operating system and reading gist tokens and whatnot, you need to opt into that, right? Like there is no secure way for a program to read environment variables and access the internet in some unbounded way. But by kind of restricting this and at least being able to observe and click through these things and agree, very much like in the web browser when you access a website and it's like, oh, I want to access your location API or access your webcam, right? In Deno, you opt into operating system access. So that is what is meant by secure by default and what is meant by running URLs directly. It's not just URLs it can run, it can also execute NPM scripts. So you can do Deno run npm : QCon is a little NPM package that prints out some ASCII art. And I'm just going to try to have it say QCon hello. For some reason, the npm package QCon wants access to my current working directory, so we'll allow that. It's also trying to read its own package JSON file. It's a little bit weird. And it's also trying to read a .cow file, which I assume is the ASCII art. But once I grant that access, it can indeed print out this stuff. And of course, you can bypass all of these permission checks with allow read, which just allows you to read files from your disk without writing them, without getting network access, without getting environment variables. And so in this way, you can execute things with some degree of confidence, right? So Deno is a single executable, so I will just demo that. It's a relatively large executable, but I mean, are you ever going to know that if I didn't tell you that? It's 100 megabytes, but it contains quite a lot of functionality, and it is, I would say, pretty tight. It doesn't link to too many system libraries. This is what we've got it linked to. So it is kind of this one file that you need to do all of your TypeScript and JavaScript functionality. We do ship on Mac, Linux, and Windows, all fully supported. And this, yeah, I think it's kind of a nice property that this executable is all you need. You only need that one file, and when you install Deno, you literally install a single executable file. I mentioned that Deno takes web standards seriously, and this is a subset of some of the APIs that Deno supports. So, of course, global this is this annoying name for the global scope that TC39 invented, but that is the web standard. WebAssembly, of course. Web crypto is supported. Web workers are supported. That's how you do kind of parallel computation in Deno, just like in the browser. Transform stream, event target, abort controller, location APIs, the location object, form data, request and response, window variable, window.close, local storage. It goes quite deep. And just to demo this a little bit, I want to gzip a file with web standards here. And let me Deno init QCon 10. I'm using 10 because I've been doing this for hours now, trying to. I think I've got a lot of QCon directories here. So let me open up VS Code and potentially make that big enough that you're able to view this. So what I've run is a Deno init script that creates a few files here. And what I can do is Deno run main ts, and that adds two numbers together. No big deal. I'm going to just delete this stuff, and what I want to do is open a file. I want to open up two files. I'll open up etc password, and then I'm going to open up a file out.gz, and I'm going to compress that text file into a gzip file, but using web streams here. So deno.open etc password is the first one. And that's an async operation, and I'm going to await it. By the way, top level await here. So this is the source file that we're reading from, and then I'm going to open up a destination file, Deno open. Let's call it out.gz in the current directory, and we want this to be write is true and create is true. We'll let Copilot kind of do a lot of the work there. And so what we can do is this file, this src file, has a property on it, readable, which is actually a readable stream. And I can do pipe through, again, web standard APIs, new compression stream for gzip. This is all browser, oops. Problem with Copilot is you can't really trust it. And then we're going to pipe through this gzip compression stream, and then pipe to the destination that's writable, right? So this is a very web standard way of gzipping a file. Let's try to run that guy. So of course, it's trying to access etc password, so we have to allow that. So yes, it's trying to get write access to this out.gz file, and there. Hopefully we've created an out.gz file, and hopefully that file is slightly less than this password file, which that appears to be the case. Okay, so. Yeah, web standard APIs, very deep, and in particular when it comes to streaming APIs and web servers, Deno has it all very, very deeply covered, right? If you want to stream a response and pipe it through something else, all of this is dealt with standard APIs. I mentioned that Deno has node compatibility. And this was not an original goal of Deno. Deno kind of set out with blazing new trails. But what we've found over time is that actually there is a lot of code that depends on NPM and Node, and that people are unable to operate in this world effectively without being able to link to NPM packages, and NPM packages, of course, are built on top of Node built-in APIs. And so we actually have this all pretty much implemented at this point. There are, of course, many places where this falls through, but just as a demo of this, I'm going to import the Node file system. So import from node:/fs, and I'll do read file sync. Right? Before I was using the Deno.apis, that's some global object that provides all of the Deno APIs. And here I'm just going to do read file sync. I'll use my same file here, and this thing returns a node buffer, not to be confused with a web standard buffer. Very different things. And I'll just console log that out, right? Just as a demo of running a Node project. Of course, The security still applies here, so even though you're going through the built-in Node APIs, you do not actually have access to the file system without allowing that. So you have to grant that either through the permission prompt or through flags. And there we go. We've read etc password now with an output at a buffer. Deno's support of Node APIs is not, maybe this FS API is rather superficial, but I would say this goes pretty deep. It's not 100% complete, but it is deep. I do want to mention this project called DNT. I won't demo this, but DNT stands for Deno Node Transform. The problem with NPM packages, there's so many problems with NPM packages, but one of the big problems is that you kind of need to provide different transpilation targets, right? Are you building an ESM module? Are you building a common JS module? Like what sort of engines are you targeting? It's pretty hard to code that up properly by hand. There's a lot of things to get wrong. And at this point, we are thinking of treating NPM packages as essentially compilation targets rather than things that people write by hand themselves because it is so complex and so easy to get wrong. DNT takes care of this for you. It will output a proper NPM module with common JS support and ESM support and creates tests for you and does this all in a cross-platform way that allows them, can be tested on Node and can polyfill any things that are not in Node, kind of provides you with toolings there. And so, I just wanted to advertise this as, even if you're not using Deno, this is a great tooling to actually distribute NPM packages. As a more serious example, or like a slightly more serious example, let's do some express coding here. So let me delete this here, and I'm going to. So in Deno, like, you don't need to set up this package JSON file. You can just import things, right? You can use a package JSON file, but it's kind of boilerplate at some point. So let me do this. Import express from npm:/express, a slightly different import here. And then let me see here. I'm going to const app equals express, and then I'm going to, thank you. And then app.listen, app.listen is something, and console log listening on HEP localhost 3000, I guess. Just throw together my little Express app here. And let's see if this thing is running. For some reason, it wants to access the CWD. I think this must be something weird with Express. Also, environment variables. And also, of course, it wants to listen on port 3000. But I think once we've jumped through those hoops, we should be able to curl localhost at port 3000 and get hello world. Great. In order to not have to repeat that all the time, let me just add some command line flags here. Allow read, allow env, allow net, not allow write. There is a couple of red squigglies here that because I'm using TypeScript, because this is kind of transparent TypeScript support here, is giving me some errors and saying, oh, this response has an any type. The problem with Express, because it's kind of a dated package, is that it doesn't actually distribute TypeScript types itself, and so we have this, admittedly, somewhat nasty little pragma that you need to do here, where you have to link this import statement with, npm:/types here to get modern npm packages will actually distribute types link them in the package JSON, and so this shouldn't be necessary. But just because Express is so old, you kind of have to give a hint to the compiler about how to do this. And we're still getting one little squiggly here. Oh, it's just never read. Okay, whatever. So okay, now we have kind of our proper little Express server. In fact, let me just make this a little bit better. We've got this -- watch command built into Deno. So let me just add my flags here to this this Deno task. Deno task is something like npm scripts. So I can just do Deno task dev, and now it's going to reload the server every time I change any files here. So if I want to change that from hello to just hello, it will reload that. Okay, great. So we've got our little Express server. Yeah, let me. We'll keep working with that example, but just as kind of a interlude, here's some of the tooling built into Deno. I'll leave it to you to kind of browse all of this on your own. But the one that I wanted to point out here is standalone executables. So let's take this little Express server that we've built, and let's try to Deno compile main TS. Okay, we do need to provide, what is this going to do? This is going to take all of the dependencies, including all of the Express and NPM dependencies, package it up into a single executable file, and output it so that we can distribute this single file that is this tiny little Express server. I'm going to do this, and it looks like it worked. There's my QCon 10 executable, but now it's still prompting me for permissions. So actually what I want to do is provide a little bit more allow net, allow env, allow read, provide these permissions to the compiled output so that we can actually run this without flags. So now we've got this little distributable QCon 10 file that is an ARM64 Macintosh executable here, and you can package this up and send it around. It is hermetic. It will persist into the future, right? It doesn't depend on any external things. It is not downloading packages from NPM. It includes all of the dependencies there. What's super cool about this, though, is that we can do this trick with Target. And Target allows you to cross-compile for different platforms. So let's say that we wanted to actually output QCon 10.exe for distribution on Windows. And yeah, we'll provide a target, and we'll do QCon 10.exe. And there we go. We've got our hopefully QCon 10.exe. We've got our exe file that should be executable on MS Windows that contains all of these dependencies just like the previous one. And similarly, you can target Linux, of course. This is extremely convenient for distributing code. This is kind of how you do not want to distribute a tarball with all of these dependencies, right? Like you want to email somebody one file and say, execute this thing. So I should mention here that Deno is a company, and we are also building commercial product. And our commercial product is taking a lot of the technology. By the way, all of the stuff that I've been showing you, this is all open source, of course, MIT licensed, very, very, very free stuff. We take that infrastructure, combine it with some proprietary stuff, and we are building a serverless platform. And I argue that this is the easiest serverless platform you have ever seen. It is quite robust. So it is first and foremost serverless, and so scales to 0 is a quite important goal for anything that we're developing inside Deno Deploy. It, of course, supports NPM packages and Deno software in general. It has built-in storage and compute, which is really interesting when you start getting into this. And those also have serverless aspects to them. It is low latency everywhere. So if you have a user in Japan, when you deploy to Deno Deploy, they will get served locally in Japan rather than having to make a round-the-world hop to your application server. It is focused on JavaScript, and because of that, we can deliver very fast cold start times. We are just starting up a little isolate. So this is not a general purpose serverless system like Lambda. This is by the way, I mean, I started this talk by saying that JavaScript has a future unlike all other technologies, right? Like I mean, maybe semiconductor technology, fair to guess is going to be here 5 years from now. But in these kind of high-level technologies, JavaScript is pretty unique in that we can say that it is going to be there in the future, and that is why we feel comfortable building a system specifically for JavaScript, right? This is a platform unlike, say, Python. It does have different things, and yeah, I would just say that this system is production ready and serving real traffic. So for example, Netlify Edge Functions is built on top of Deno Deploy. So this is actually supporting quite a lot of load, despite my very poor slide craftsmanship here. So yeah, let's try to take our Express server and deploy it to Deno Deploy and see what that's like. What I'm going to do is go to the website, dash.deno.com. This is what Deno Deploy looks like. I'm going to create a new project, and I'm going to create a new blank project here. It's given me a name, Hungry Boar 45, but just so for good memory, we'll call it QCon 10. And now I have to deploy it. So I can go look up the command for this, but I know what it is. Deploy CTL. So what I'm going to do is just say, give it the project name, deploy CTL, deploy. And then I have to give it the main file that it's going to run. So I'll give this main.ts. And before I execute this, let me just delete these executables that I outputted here, so it doesn't inadvertently upload those. And let me also just give the prod flag. So this is uploading my JavaScript code to Deno Deploy and making a deployment. And before you know it, you've got this subdomain, which we can curl, and hopefully gives me a hello response. This is maybe seemingly quite trivial, but this has deployed worldwide in the time that we've run this command, right? When you access this subdomain, and if you access this 2 years from now, hopefully this will continue to be persisted, right? This is running in a serverless way. Costs us essentially nothing to run a site that gets no traffic. So to take this example maybe one step further, I mentioned that this has some state involved here. So what we're doing right now is just responding with hello. But let's make this slightly more realistic. Obviously, real websites are going to be accessing databases and whatnot. You can, of course, connect to your Postgres website. Or your Postgres database. You can of course, connect to MongoDB. But what we've added in Deno Deploy is this Deno KV, which is a very simple serverless database that is geared towards application state, specifically in JavaScript. So it is very critically, zero configuration to set up. So it will just be there out of the box. You'll see that shortly. It does have ACID transactions. So you can use this for real consistent state. It scales to 0, of course. It's built into Deno Deploy. And I won't talk about this, but under the hood, it's FoundationDB, which is a very robust industrial database that is running, for example, Snowflake and iCloud at Apple. A very serious key value database that provides all of these primitives. We, of course, are not engineering a database from scratch. That would be absolute insanity. What we are trying to do is provide a very simple state mechanism that you can use in JavaScript for very simple states that you might need to persist, and you would be surprised at how useful this actually is. It's a KV, it's a key value database, and it operates on JavaScript objects. So it's important to note that the keys are not strings, but JavaScript arrays. You can think of this as like a directory structure, a hierarchical directory. And those keys can be strings, or the values in those arrays can be strings or integers or actually byte arrays. And the values can be any JavaScript object, not just a JSON serializable JavaScript object. So you can dump date objects in there. You can dump big ints. You can dump uint8 arrays. It's very transparently nice. So let's try to add a little bit of state to this system, to be a little cautious of the time here. So what I'm going to do is first of all open the database. So Deno.openKV is the access to this, and you have to await that. This is how you access it, and you do const kv equals that. I'm getting a little red squiggly line around this because it's like, oh, what is this openkv thing? This stuff is still in beta and behind the unstable flag, so I do need to go into my settings and enable the unstable APIs in Deno. And I just click this thing. This is, and it should go away. Okay, great. Just making the LSP happy. What I want to do is just set a real simple value here. As I said, the keys are arrays, and so I'm going to just start a key that's called counter, which is an array with a single string in it, and I am going to set this to the value 0. And I have to await this, and then I'm going to get this counter and see, hopefully get back 0. So const, let's call this v, and I'll just console log that. Let's run this file again and see if I haven't really messed this up. So Deno task dev. And it's giving me another warning here. OpenKV is not a function. Again, this is because I don't have the unstable flag. Let me just add unstable in here and try this again. There we go. Okay, so now when I've run this file, kind of at the top level, I've stored a key and gotten a value back out of it. Okay, I guess that's interesting. Let me just give a name to this key here. And delete this code. And what I want to do is return, actually, let me save some of this code. Let me get this counter out of here and kind of return it in the response of this express server here. So I'm going to await this kv.get, and then I'm going to return hello, maybe I'll say counter. With the value of that counter, and I've got a little red squiggly here, and it's saying that await expressions can only be allowed inside async functions. Got to turn this into an async, and that should make it happy. And let's just test it. Curl localhost. Okay, so I'm getting counter is 0. So then the question is, like, how do I increment this counter? And by the way, we're going to deploy this to Deno deploy, where it's going to be propagated all around the world. So how are we going to increment that counter? Let me show you. So you can do atomic transactions. I mentioned ACID transactions in KV. So you can do kv.atomic sum. We're going to increment this key, this counter key that we've got, and we'll increment it by 1. And let's see if that works. So we'll curl this, and it is not working. Let's see. We got to, oh, I know. We have to commit this. Commit the transaction. So curl, it has crashed because this is a non-U64 value in the database. Let me just, this is where the demos fall apart, where I run into errors, right? Let me use key there, and let's just use a different value here. I won't explain the error, but okay, let's see. counter 1, counter 2, counter 3. Okay, so we are now incrementing this value from the database. And my claim here is that this is, although just a counter, can now be deployed to this serverless environment. And I'll just run the same command that I did before, this deploy CTL thing. Oops. So we'll do deploy CTL, deploy prod project equals QCon 10 main.ts. Okay, so now my claim here is that this is, although a very simple server still, somewhat stateful. So every time I'm accessing this QCon, the counter is increasing quite rapidly. Presumably, like you guys are doing this. This thing is deployed worldwide. And if I go into my project page here on Deno deploy, you can get this KV tab. And inside of this, you can see some details about this. The right region for the KV values is in US East. And there are read replicas for this. Actually, the only one that's turned on right now is US East 4, but we've got 2 others available. So we could turn on the Los Angeles read replica. In fact, let's just do that. Takes a second. This will replicate the data to Los Angeles, so that when we read from that value, we are getting something. So I'll leave it at that. But let's suffice it to say that this is pretty useful in many situations where you need to share state between different isolates running in different regions. I don't think it takes the place of a real relational database. If you have a users table and that sort of stuff, you probably want to manage that with migrations. But there are many situations, in particular like session storage, where something like this becomes very valuable. I'm running a bit out of time, so I'll stop my demos there. But let me just mention that we also have KV Queues. And this is a simple way of doing at least once delivery. And this is in particular very useful for webhooks, where you don't want to do a bunch of computation inside the webhook, right? What you want to do is queue up something and do that asynchronous from the webhook request. So yeah, I'll just leave the link there for you, and I will pop up my email address and say that you're very welcome to email me and carry on the discussion there, or ask me a question now.
Awesome. Let's give Brian a big round of applause.
Could I get your spicy take on bun? Your thoughts on bun?
Yeah, I guess my spicy take is that JavaScript is super important, and there is a lot of room for improvement here. Deno started off, as I mentioned, not node compatible, and we were kind of operating in a world where pushing at what is possible beyond NPM, and I think the Bun project has created some good competition in that sense. It's just like, no, actually, this is very important for stuff, and I think that pushes our work in Deno to be receptive to the needs of NPM users, right? We can't just kind of elbow our way into a developer community and say that you need to use HGPS imports for everything. So very good in that sense. I really like Rust. I'm very confident that like a very heavily typed, very complex system like what we are building is manageable quite well in Rust. Yeah, I mean, we continue to develop with urgency, and we will see where this goes in the future.
Any other questions for Ryan?
Hi, thank you so much. I'm curious if you thought about the psychology of the permission system in terms of, users or developers will just say allow all, or how do you deal with that kind of decision fatigue?
It's at least, yeah, I mean, of course, when you're developing yourself on some software, you're just going to do allow all because like you know what you're running, right? But it is the JavaScript V8 engine provides a very secure sandbox, and I think it's a real loss if you just throw that away and say like, no, you have unrestricted access to the operating system bar nothing. So yeah, I mean, it gets in your way, but I think that's good. Sure, maybe it introduces decision fatigue and maybe people do allow all. That's their problem. Better to have the choice than to not. I think there's work that we can do in kind of the ergonomics of it to make it a little bit more usable and user-friendly, but generally, we are pretty confident with our secure by default design.
Hi. So the slide where you were talking about supporting web standard APIs, that makes a ton of sense, but I sort of read between the lines as that being a goal to allow people to use the same code like in the browser that they would in a Deno environment in some cases, which seems like a noble goal, but then your import statements are a little bit different, so they wouldn't work in a browser. So I'm kind of curious, like, how those pieces fit together.
I mean, we are touching the file system. We are creating servers. We're doing all sorts of stuff that is not going to run in the web browser. So yeah, I mean, the goal isn't necessarily that you can, we're writing in TypeScript in particular, that is not going to run in the web browser. So, just because there is something that you're doing differently on server-side JavaScript doesn't mean we need to reinvent the world. I think a big problem in the Node world, for example, has been the HTTP request API, right? When I made that API, there was no fetch, right? I just invented it, right? I don't know, let's import HTTP, let request, blah, blah, blah. And that was fine until fetch got invented. And then there was this huge gap for many, many years, right? Thankfully these days Node is fixing things, and I think in the next release, actually fetch is going to be very well supported. But I think just because you can't run TypeScript in the web browser or you don't have npm imports doesn't mean that we should just throw off all compatibility. I think having as much overlap as, think of it as a Venn diagram, right? We want that Venn diagram to be as close as possible. But yes, of course, it's a server-side JavaScript system. It is not going to do exactly the same things as browsers, but let's not just make it two distinct separate systems. That creates a lot of confusion for users.
One last question.
Yeah, great presentation. I'm wondering if Deno KV would be part of the open source implementation, or is that a commercial product?
You saw me running it locally, right? And I was doing this like curl local. I killed the server, but the question is what is it doing there? Locally, it's actually using a SQLite database, kind of hidden behind the scenes. And the purpose of that is for testing, so that you can develop your KV applications and kind of check the semantics of it, run your unit tests without having to set up some sort of mock KV server, right? That is all open source and fine, and you're kind of free to take that and do what you want. Obviously, you can ignore it if you want to, too. The FoundationDB access comes in when you deploy to oh, geez. The FoundationDB access comes when you deploy to Deno deploy. And by the way, there are ways to connect, for example, Node to the foundation, the hosted FoundationDB, even if you're not running in Deno deploy. That's called KV Connect. So it is a hosted solution, and it is it is a proprietary commercial operation, but the open, first of all, you're free to ignore it, and you can run it locally, and the SQLite version of it is open. open source.
Awesome. One last big round of applause for Ryan. Thanks for speaking today.
Thank you. Thank you.